Hi, I am myself Dr. R.B.Dubey. Today I am going to present the chapter of first chapter. So basically I will start the lecture of the solution. Solution is the first chapter of volume 1 of class 12 NCERT book, and it is a very important for the questions comes from the your competitive level and as well as the in board examinations. So first I would like idea give the how will you understand about the solutions. There is some content line we will just discuss today this lecture. First of I will discuss about the mixture. Then after type of mixture, there is a three type of the mixture of the solid of state, solid, liquid, and gas. We will just describe about that. And today lectures I will discuss about that Henry's law and what is the application of Henry's and Raoult's law, ideal and non-ideal. Today this is my first volume. The content I would like to express my point of visions. What is the mixture? The mixture, as we know that the mixture is the actually constituents of the two and more than two elements which combine in a certain ratio. The mixture maybe you can say that like a sugar and water. This is also one of the mixture, and like a what happens like a brass and bronze and like a silver metals when you will talk about that, like a zinc and copper, they are the in a brass, they are combined together, that is the metal of the mixture, metal like ores of this mixture. Then you can say that like what I'm bronze metal, bronze means like a copper and tin, or like a silver metals like a German silver, then zinc, copper, nickel. They are the one of most of the examples of this mixture. But I'm coming into the points of mixture. I explain about you. But I'm coming into the point of the types of the solution. The types of the solution we will describe about the type of solution, basically homogeneous and heterogeneous. On the basis we will study about it. All the students try to understand what is a homogeneous. You are studying from the class 7 onwards to till now. That is the homogeneous. Homogeneous mixture may be defined that if the composition and the components of the solute which dissolve into the solvent, they will be dissolved uniformly throughout the solution. Component and compositions, they have the determining but in uniform throughout the solution. But in case of the heterogeneous, there is the composition and component of the element which is the not uniform, not uniformly distributed in the solution. For example, chalk, for example, like a sand, the heterogeneous on the basis we can be analysis by study about, and homogeneous salt and sugar. Now solid, liquid and gas. There is a, we see that liquid in liquid mixture, solid in liquid mixture, solid like gas in liquid, gas in solid. So 9 type of this actually mixture we will discuss about and solution preparation. Now I am going to expression about the concentration of the solution while you study about mass percentage, volume percentage, parts per billion, mole fraction, molality, like this. So first I would like to draw my kind attention on the mass, actually what I am telling you that mixture. What will happen, the total number of the mass of the component. When the component divided by total number of the mass of the component, so mass of the component divided by the total number of the mass of component into 100, when we can study about the mass percentage. Mass percentage, for example, I mean to say that 10 gram. 10 gram like a sucrose dissolve into the 90 ml of water. So they will be preparation in the 100%. So you can say that. Volume by volume we can say that 10% ethanol dissolve into the 90 ml of water. So we can prepare for the volume in percentage. And always we will study about the percentage into the 100. As similar, but there is some parts per million. The parts per million is a very most important to study about The total number, the parts per million means the component of the parts of elements, and divided by total number of the parts into 10 to the power 6. So if you will study about the any components into the parts of per million, in millions time you will be calculate. So parts per million means that is the traces quantity of the component when you will study about in parts per million. ppm, it is a shortcut name or shortcut say that parts per million. So I am going to explain what is the molarity. The molarity is basically what happened. Before the molarity, we must know about the mole fractions. The mole fractions may be that if the number of the moles in a ratio, in a fraction form, either you will consider of mole fraction XA, XB, XC, XD like this way. That is the number of the moles Na. So this is the what is the happening of the mole fraction. First part I have explained about the mole fraction. Now I will start the mole fraction. Mole fraction is suppose XA and XB. So calculate the XA equal to XA by divided by XA plus XB. So what is the XA for the, this is the mole fraction for the solute, and this is the total is the solute plus solvent. Similarly we will study about the XB. XB is subscript for the number of the moles of solute, and this is the solute plus solvent. So we can be determine this XA plus XB, and this is the what will be happen. So XA and XB, so we will take NA by NA plus NB. Sorry, you will write down NA and NA and NA NB. Here you will write down NB and A plus NB. So okay, so XA is the mole fraction of A. This is the mole fraction of B. So this is the NA is the number of the moles of solute, and it is the number of the moles of solute and solvent plus NB equal to Na plus NB. So what will be happen? XA plus XB equal to Na plus NB divided by Na plus NB. You will take LCM. So you can learn the mole fractions. So it will cancel. Then XA plus XB equal to 1. So XB equal to, you can write down 1 minus XA. So this is the basically you can be study about the mole fraction. So this is the thoroughly mathematically derivation of the mole fraction. And what is the molarity? Molarity may be defined that is the number of the moles of a solute which is dissolved in a 1 liter of a solution. 1 liter of solution, I will explain about that. Just like a, what is the molarity? Molarity means that if the molarity will be defined about the number of the moles of a solute and number of the moles of a solute in a solution. So this molarity basically dissolve in a number of the liter. Liter means 1000. 1 liter equal to 1000 milliliter. So molarity equal to WB divided by MB into V into 1000. This is the 1000. 1 liter equal to 1000. 1 liter equal to 1000 milliliter. So WB is the weight of the solute, and MB is the actually mass. So in a mass in a 1 liter of your solution. So molarity we can molarity you can define that, and molarity is similar, but there is some difference. The basically what will be happen, the molarity may be defined that if the number of the moles of a solute which is dissolved in a 1 kg of the solvent, means 1 kg of the solvent. Okay, so you can understand. And normality, you can say that normality means normality equal to WB by EB in, divided V. V is the volume, E is the equivalent. So what is the proper definition? The normality may be defined that gram equivalent of weight of solute dissolved in a 1 liter of solution. So we can say that normality and molarity. Here is the same thing is the normality equal to n into molarity. The concept is the molarity and molality and normality I have explained. Now secondary thing is that what is the difference between the molality and molarity? Molality parts per million and mass, total number of mass and parts per million, molarity and molality and mole fraction, they are independent the temperature. Only molarity जो होता है वो that is the depend on the temperature.